Hello. Hi, guys. Welcome back to another episode of Code and Create. It's been a few weeks since we've been out. Had a little bit of a break, but now we're back. We've got exciting two-week session here with Neeraj. You can see with me today. We're going to be going through today the foundation, or an introduction, if you like, to Apache Spark. So yeah, two-part episode. This week is a bit more of a basic introduction to Apache Spark, and next week's going to be focused a bit more on the data analysis within Apache Spark. So yeah, as I mentioned, I'm joined by Neeraj Bhadani, data scientist at Expedia. Hi Neeraj, how are you?
Hey, Joy. I'm doing good, thank you. How are you?
Yes, not bad, mate, not bad, thank you. It's been nice and sunny here today, which is always a bonus. Whereabouts are you?
Yeah, it's a bit of cloudy here, but yeah, the good thing is it's not raining.
Well, exactly, yeah. So let us know where you're tuning in from, guys. If you're on LinkedIn, let us know in the comments. If you are using viewing on Crowdcast, then use the chat bar over there, I think it is. Let us know where you're tuning in from. Always nice to see. We've got a Q&A that we're going to be doing with Neeraj following his presentation and our chat. If you've got a question, any question, there's an ask a question button below on Crowdcast that you can use. Again, if you're on LinkedIn, ask us in the comments. We'll be keeping an eye on that, and we'll try and get around to as many questions as possible at the end. I'm sure there'll be a few. So Neeraj's got a presentation that we're going to go through today, so it's going to last about half hour. We'll be chatting through that, and then he's going to give us a little demo at the end before we start the Q&A. So yeah, we've also before I forget, we've got a poll set up, a few polls down there, just bit of fun really, just to get involved with, just to see the people that are tuning in. If you've ever used Apache Spark before, it's always nice to see. And of course, if you've signed up for next week's event yet, so do it now. All right, without further ado then, Neeraj, should we crack on?
Okay, thanks, Joy. So let me quickly share my screen and the presentation. So should be okay now. Okay, so can you see my screen okay?
Yeah, all good, mate.
Okay, great. So welcome everybody to this particular session where we will discuss the basics of Apache Spark, as Joy mentioned. And once upon a warm welcome to everybody. Myself, Neeraj, working as a data scientist at Expedia Group. So this is a brief introduction about me. And I have kept my LinkedIn and the Medium profile just in case you want to get in touch post session, or if you want to follow me on the Medium, where I generally try to post some of the stuff around the big data and the Spark. Now, the agenda for today's session is we're going to discuss the Hadoop ecosystem, because I could see in the polls that some of you might not have used Spark. So it's a good idea to discuss like how it has been evolved, where exactly it fits into the ecosystem of Hadoop. We'll also briefly chat about the limitations of the MapReduce and why Spark evolved. What is Apache Spark, the different components, what we have in the Apache Spark, the architecture, and then we will finish the session with the discussion of the RDDs. So now, let's first of all try to understand the Hadoop ecosystem. Now, in order to understand the Hadoop ecosystem, what I will do is I would like to take a very simple example. And let's say we have some sort of logs, and these logs could be your application logs or your server logs, or any type of logs which you would like to analyze using the Hadoop ecosystem. Now, in order to analyze your logs using the Hadoop ecosystem, first of all, what you would like is you would like to ingest your logs. And if I talk about the data which you would like to ingest, that data could be like can be divided into two categories. One is the structured data, another one is the unstructured data. Now, for example, if you would like to ingest the unstructured data, you have a tool, something called as a Kafka or Flume, which you can use to ingest the data. If you have structured data, you can use Scoop to ingest the data into the Hadoop ecosystem. Now, once you ingest the data, definitely you will require some sort of storage where you would like to keep your data. So you can use either the HDFS, which is the Hadoop distributed file system, or you can use any other blob storage by the cloud providers like S3, GCS, or any other file system which is provided by Hadoop. Then on the top of that, you have another layer called as Yarn or Mesos. This is basically a resource management layer, because in the Hadoop ecosystem, you have a lot of different services. So you need a different component to manage the various services what we have. So this is why we have Yarn stands for yet another resource negotiator. This is basically a resource management component into the Hadoop ecosystem, or you can use Mesos as a resource manager for Spark. On top of that, we have the processing component. So earlier we used to have MapReduce, and now we can say we have a Spark, or sometimes we also call it as a Spark core. And on the top of MapReduce, we have some sort of high-level tools which were built by the different organizations. So we have something called as a Pig or Hive to do some sort of data analysis. However, with Spark, we have certain libraries or certain modules with the real-time data, graphics to process the graph-like data, and MLlib to process like to build your machine learning models, and Spark. Now, the idea behind discussing this particular ecosystem is to give you a couple of important points. So first of all, Spark is a component which resides into the Hadoop ecosystem. So the one which you could see as a gray box here, this box is something called as a Spark. And in that, this is how the structure of Spark looks like, which has multiple modules in it. Okay. And the second important point with respect to Spark is this is a processing component. So it won't provide any storage. In order to store the data, you need to use some sort of storage, either as a HDFS, S3, or GCS, but it won't provide any storage. So this is only a processing component. And you could see in the architecture, it is residing parallel to the MapReduce, which used to be a processing engine prior to the Spark.
So Neeraj, you mentioned that in terms of actually storing the data, can you hear me?
Yeah, I can hear you.
Okay, sorry, I think my connection, I don't know if it's your connection or my connection, Neeraj, but I think it's, yeah, it's shifting a bit there. It seems to be okay now. But just, yeah, back on the ecosystem slide, you mentioned about storing the data for Spark. So what sources can you use to store the data on Spark?
Absolutely, that's a very good question. So in order to use the data storage or the data stores or the data types, what you can use. So for example, if you have your data as a CSV file or as a Parquet file or as an Avro file, JSON file, or maybe if you have data stored into your Hive tables, you can read those data into Spark. You can process those data, and you can store that data back to the different sources. For example, you would like to, let's say, read the data from Oracle or any other RDBMS as well. So what you can do is you can read the data from the Oracle or any other RDBMS. You can process the data into Spark, and you can save that data back to, let's say, Hive table or a CSV file. So these are the different type of data sources you can use with Spark.
Okay, cool.
Okay, great. Thanks for a question, Joey.
No, that's all right. Sorry for interrupting. You carry on.
No, absolutely. Great. So let's first of all discuss the limitations of the MapReduce, which will describe why we have Spark. So with MapReduce, it was very slow in processing speed because it was using disk a lot. It was only meant for the batch processing, so it was not really good for the streaming loads. It was not really efficient for the iterative processing because of the fact that it used disk a lot, which makes it very complex and also very inefficient. It was not very easy to use because even in order to perform a very trivial operations, you need to write a lot of different codes to make it work. So these were some of the limitations of the MapReduce. So that's how the Spark was come into picture. It was initially started as UC Berkeley as a project. It is very fast and a general purpose computing system. Now, we will discuss about the fast and the general purpose in the upcoming slide. It is very popular for the iterative machine learning algorithms because of the fact that it is an in-memory, it provides an in-memory computing capability. It will try to keep the data in memory, which makes it very popular for the iterative problems, which is basically machine learning algorithms. Also, if we would like to work with Spark, it provides various high-level APIs, for example, Java, Scala, Python, R, or even SQL. So for example, if you are familiar with any one of the language, you can absolutely use Spark and leverage the capabilities of the Spark. And it is very well integrated with the Hadoop and its ecosystem, and you can use it very nicely with the Hadoop ecosystem.
So Neeraj, what out of those several APIs there, I mean, is one there that you think works best within Apache Spark out of those options?
So, okay, in order to answer that question, so I would not say like the one would work better than the other. Rather, what I would like to do is I would like to give you a context which can help you to decide which one to use. So, a couple of points could be most of the Spark code is written in Scala. So that is a very important point to know, that most of the Spark code is written in Scala. Okay. Now, the other important points is, for example, if you would like to start a particular project and you would like to decide which particular...
No, sorry just to interrupt you there. It sounds like your microphone might be rubbing on your shirt a little bit there.
Oh, sorry. Is it okay now?
Yeah, I just heard a bit of friction, that's all.
Okay, sorry for that.
No, that's fine.
So what I was saying is, for example, if you would like to start a particular project and within your team, you have the capabilities of, let's say, a Python. So your team members already know Python, which means that it makes it very convenient for you to choose the Python API, because then the team members need not to learn the other APIs, and you can focus on the Spark rather than learning any other different language. So that is another argument I can say. The third is, even if someone is not familiar with any one of the language like Java, Scala, Python, or R, and they are only familiar with the SQL language, so still they can leverage the capabilities of Spark with only the SQL queries. And behind the scene, it will convert your SQL queries into the native Spark code, which runs exactly same as if you are running either using a Scala or Python or any other API.
So you can take advantage of all of Apache Spark's capabilities, even from using either SQL or from using Scala.
Yes, absolutely. Absolutely. However, like in the next session, I will going to discuss a couple of points to mention that where you should use SQL, or where you can use like some of the other languages. So there is a bit of difference, not in terms of the performance, but in terms of the usability. You can still find that in what cases you can use SQL, or in what cases you can use any other language. But with respect to language, the one you are comfortable with, we should go for first as a part of selection.
Okay, cool. Well, we'll go into a bit more technical detail on that on next week's session then, Neeraj.
Okay, great. Thanks. The next, like we talk about, the Spark is an in-memory computing capability. It provides the in-memory computing capability. So in order to understand that, let's take a very simple example that we would like to solve a particular iterative problem using, let's say, the MapReduce and the Spark, and we will try to see the difference between both of them. So first of all, let's say our data resides on HDFS. then the MapReduce job will read the data in the first iteration, and it will store the data onto the disk. And this data is nothing but an intermediate data, which is the output of the first iteration. In the second iteration, what the MapReduce job will do is it will read the data from the disk. It will read the data from the disk, and it will store the data again to the disk in the second iteration. And let's say this particular problem will take 100 iterations, and the final result will be stored onto the HDFS. Okay. Now, there are a couple of important points to note here. If you look at this particular operation, this is basically a write to disk, which means that our MapReduce job will try to write the data onto the disk. And in the next iteration, our MapReduce job will try to read the data from the disk. Okay. Now, let's try to perform the same iterative problem on the Spark. Again, we'll read the data from, let's say, the HDFS. Spark job will read the data into the first iteration. It will keep the data in memory as it provides the in-memory capability. In the second iteration, Spark will read the data from the memory. It will store the data back to the memory. And let's say this also take the 100 iterations, and the final result will be saved to the HDFS because Spark don't have any storage, so it has to store the data somewhere external to it.
Okay, so I know you mentioned MapReduce earlier and the advantages and some disadvantages of it. So what is MapReduce then in terms of Spark itself? Obviously, speaking for myself and other people that might not have used Apache Spark before.
Okay, so before Spark, when the Hadoop evolves, so the processing engine used to be the MapReduce. So the MapReduce was the processing engine or the processing component into the Hadoop ecosystem. And then later on, we got the Spark, which is you can say a more efficient and the more performant, and it has a lot more other advantages of it.
Okay, cool.
And one more important advantage you could see here. So these are the operations from the memory. So here we are trying to write the data to the memory and read the data from the memory. And we know that the latency while reading and writing with the memory is less as compared to the disk, which makes it faster than the MapReduce. Okay.
Okay. Is there ever any situation where there's not enough memory or Spark won't fit data into its own memory?
Yes, absolutely. It could always be the case, because at one side we are talking about the big data. So we are talking about we would like to process the huge amount of data, and on the other hand we are talking about to keep the data in memory. So what Spark will do is Spark will try to keep the data in memory as much as it can, but if it cannot keep the memory in the memory, if it cannot keep the data in memory, it will try to spill the data to the disk. However, when the data spilling will happen, definitely there will be a performance hamper. However, Spark has a very good memory management. It will try to manage the memory by itself, and also we can also do some sort of memory management task. For example, if you're trying to process some data, we can try to only fetch the data which we are interested in, rather than fetching all of the data. So with both the techniques what we are using to write the Spark code and also the memory management, it works really well.
Okay, cool. And is there a limit to the amount of data or storage?
It depends on your hardware. So you can build a very humongous cluster with the insane amount of memory as well. Absolutely.
Okay, cool. Yeah, we've just had, I'll see a note on the old chat bar on the side. These slides will be available, and this whole presentation will be available to watch back as well. So we'll send out all the links post event. So yeah, carry on, Neeraj.
Okay, great. Now these are the different components of Spark. So it works in a master-slave architecture. So here the driver is your master, and the workers are slaves in this particular context. And this is the cluster manager, which basically manages the different resources into the cluster. And here we could see inside the driver, we have something called as a Spark context. This is nothing but a starting point of our Spark application. We'll talk about it in a minute. Now, here, this is the high-level architecture of Spark. So at the bottom, you could see Apache Spark, or sometimes we also call it as a Spark core. On the top of that, we have the different components like Spark SQL, which is basically to process the structured data, the graphics to process the graph-like data, the machine learning to build the machine learning models, and the streaming component to process the near real-time data. And we talked about the two important aspects of Spark. One is the fast, and another one is the general purpose computing engine. So fast is something which we have already covered in the previous slide. And here we could see this particular Spark is basically a general purpose. You can like read the data and you can analyze the data in a structured manner. You can read the data in a real time, and then you can also process the data and build your machine learning models. And even if you have the graph-like data, you can use Apache Spark. So this is why we say that it's a general purpose computing engine, because you can do a variety of, you can perform the variety of loads using Spark, and it only provides the computing capability. That's why we call it as a computing engine.
Cool.
Now, the bottommost layer is Apache Spark, or sometimes we also call it as a Spark core. The abstraction which is provided by Spark core is RDD, stands for Resilient Distributed Data Set. Now, we'll try to understand this from the right. So first, it's a data set, which means that it will hold the data. The second term is distributed, which means that your data will be distributed across the different nodes. Resiliency is, we'll talk in a minute. So first of all, let's try to understand this architecture. So here is a driver, and within the driver, we have the Spark context running, which is the starting point of our Spark application. And here are the workers. For example, let's say this is a simple Python list, contains the number from 1 to 9, and we are trying to create an RDD based on this list. In order to create an RDD, we have like a function called as a parallelize. And what we are doing is we are creating a RDD called as a null. Now, when this particular statement will be executed, what will happen is your data will be distributed across the different puts onto the worker. So you could see your 1, 2, 3 is on one node or one worker, 4, 5, 6 is on another worker, and 7, 8, 9 RDD, nothing but a reference to this particular data. And you could see this data is distributed. That's why we call it as a distributed data set. So this is how your RDD looks like. Now, what are the different kind of operations we can perform on the RDDs? So there are two categories of operations, or we can divide our operations into two categories. One is transformations and another one is actions. Transformations works in a lazy manner, and actions will be executed immediately. Now, what does that mean? Let's try to take a very simple example to understand the lazy behavior of Spark. Okay, so this is a very simple code of 4 lines. In the first line, we are creating a Python list. In the second line, what we are doing is we are creating an RDD based out of this list. In the third line, we are filtering the RDD based on some logic, and we are creating an even RDD. So basically, this particular logic gives us only the even numbers. And in the last line, we are just collecting the result, or we are just displaying the result onto the console in this example. Now,
so what would be the benefits of designing that in a lazy manner then, or are you about to come on to that?
Okay, so maybe once I discuss the lazy behavior, I'll answer that question. That what is benefit?
Okay,
of
cool.
this.
I'll probably jump. Yeah, I jumped the gun a bit there, I think.
Okay, sure. I'll discuss in a bit. Now, when this particular code will be executed, so what will happen? First of all, what Spark will do is Spark will try to create the DAG, which stands for the directed acyclic graph. Spark will try to create the DAG behind the scene. So when you create a Python list and perform a transformation, say parallelize, and then you got a num RDD. Then on the num RDD, say you have performed another transformation called as a filter. It will give you another RDD called as an even. Now, since the transformations are lazy, when you execute or when you perform a particular transformations, nothing will actually gonna happen until and unless you will perform an action on top of it. In other words, when you perform a various transformation, what Spark will do is Spark will only keep those transformations into a directed acyclic graph. So which means even if you have perform, even if you have executed the first three statements of creating a list, creating a num RDD, and creating an even RDD, behind the scene, nothing will gonna execute. So till this point of time, nothing has gone executed. Even if you, and I will demonstrate this in my hands-on, in my demo as well, that what it means. However, as soon as you perform an action, which is collect operation, and let's say you got the result, at this point of time, what Spark will do is, Spark will read the list, create a num RDD, create a even RDD, and display the result. So all the execution will actually happen at this point of time when you perform an action on top of it. Okay, so I often get this question that like, we have created a Spark code. Most of our code is working absolutely fine. It's just that the last statement is failing, because it might be the case that on the top you have only prepared the transformations, which basically just created a directed acyclic graph behind the scene, and that particular graph or the operations will be executed when you perform an action on top of it. Okay, now why it has been designed in this manner? So that let's say if you perform a 10 operations, so before executing all the 10 operations, Spark will know the list of operations you are trying to execute. And what Spark will do is, Spark will create the plan behind the scene. It will optimize the plan automatically, and it will optimize the plan automatically, and it will execute that particular plan. So for the inherent optimization, this particular lazy behavior has been used. Okay.
Okay, cool.
Okay. So now let's move on to our RDD example. So let's say we have executed this particular statement. So this is how our num RDD looks like. Now, when you perform an operation on the num RDD, and let's say you are trying to filter the data based on the even logic, so that you are trying to find the even numbers. So what will happen is, on each partition, this particular function will be applied, and you will it will return an even number. And this is how we could see that the processing is happening actually in parallel. So this particular function will be applied on this partition, and it will return an even number. And similarly, the case with the other partitions as well. And at last, so here we got the even numbers, but the numbers or the results is distributed across the different nodes. Now, let's say in order to collect or display the results, we can perform a collect operation, and it will return the result to the driver. However, it is always advisable not to use the collect operation into the production environment, because you could see here we are only dealing with few numbers. But what if your RDD is very huge, and if you try to collect that particular huge RDD, which means all the humongous amount of data which is distributed across the different nodes, you are trying to collect and send it to a driver. So it will definitely overwhelm your network, and it will also overwhelm your driver as well. And you may get the out of memory error if you perform the collect operations. Even if you have sufficient amount of memory, definitely it will hamper the performance of your application. So if you can avoid the collect operation, absolutely do that.
So can these RDDs be modified?
Not really, because they are immutable in nature. You can transform one RDD to another. So for example, here we have the num RDD. We cannot change the content of the RDD. However, we can transform num RDD to an even RDD using some transformation. So they are immutable in nature.
Right. Okay. Cool.
Okay.
Hence why they're resilient.
Yes, absolutely. So in terms of resilient, I would say, so for example, at some point of time, let's say your RDD have 100 partitions, and one of the partition got corrupt, which means that you will not be able to build the RDD because one of your partition is corrupt. Now, how it is resilient is, Spark will not try to rebuild the entire RDD. However, what it will do is, it will take that particular partition which has some issues, it will refer to the DAG, and it will execute only that partition, and it will build the RDD. That's how it is resilient to the failure.
I see.
Thanks, Joy, for coming there. I think I missed that point, but thanks
That's
for
fine.
bringing that up. Okay, great. And this is how the anatomy of the job looks like. So when you submit your Spark code, that is something called as a Spark application. That particular Spark application will be divided into different jobs corresponding to the actions which you are executing. And within the job, your job is divided into a different stages depending on the kind of transformation we are using, because within the transformation, some transformation could have the narrow dependency and some transformation could have the wide dependency. So it could be divided into different stages. And task is something which is the most granular component which is getting executed onto the Spark cluster. So this is how the anatomy of the Spark job looks like at a very high level. And now I would like to jump onto the demo. So
Yes.
let me just quickly share my screen.
Just while we're
So,
doing that, guys, if you've got any questions for Neeraj, we've got a few questions come in already. If you've got any questions, then get them in the question tab below, and we'll try and get round to them at the end.
okay. How can I stop sharing this screen and put up another screen, John? Can you hear me?
Yeah, let's try it again.
Yeah.
If you just try sharing your screen again now, Neeraj.
Yeah, absolutely. So hope this works. Just give me a moment. I'm trying to share.
That's fine.
It seems like my screen got frozen. I don't know, like what is happening in the live demos.
Screen frozen.
Yeah, absolutely. I'm not able to click on the share button. I could see.
Is it above your head?
I'm able to, but I got this window where I have selected the window, but when I'm clicking a share button in the next window, I'm not able to do that. It got frozen somehow.
Aha. Okay. Let me. What I'll do, Neeraj, is I'll take you off screen and I'll bring you back on, and we'll try and like reset it that way. Yeah.
Sure, sure. That would be great. That would be
I'll
great.
see you soon. Sorry about this, guys. Just bear with us. Love a bit of technical issues. I'll just try and get Neeraj back up on the screen. It happens, unfortunately. Let's see how the polls are getting on while we're waiting for Neeraj. Pretty close in terms of people that have used Apache Spark before. Slightly more on the no side, which is good. That's what this is for. It is very close though, 45% against 54%. And everyone is happily signing up for next week, which is good. Hamad, you're absolutely spot on there. It would not be a tech event with no tech issues. Yeah, not too sure if Neeraj is having a few technical problems. Let's see if we can get him up. Yeah, and we're just what I said earlier as well. We're going to be sending out all of the slides that Neeraj has put together for us, and this whole presentation will be available to watch back. You can share it around with colleagues, friends, whoever it may be, so they can watch it back. It will be up on our Orbis Consultants LinkedIn channel, Orbis Connect's YouTube as well, and we've got Neeraj back now, which is good timing.
So just
You hear me,
give a
Neeraj?
moment. Yeah, I can hear you. Can you hear me?
I can indeed.
Okay, great. So just give me a moment. I need to restart my browser. So I'm just bringing up the demo. So just give me a moment, please.
Yeah, no worries.
Sorry for this. I don't know what happened, but
No, it's all
maybe
right. Like Hamad said in the chat bar, it wouldn't be a tech event without any tech issues. So
thanks, absolutely, thanks for that. So almost there. So Okay. Meanwhile, just to give a brief background regarding the demo. So
Yeah.
definitely I'll going to demonstrate what we are going to do, like the Apache Spark. However, the infrastructure, what I'm using the GCP infrastructure. So I'm using the managed service of GCP, which is the data proc. And while doing the demo, I will going to use the hosted Jupyter notebooks, which is inside the data proc. So I
Using
think
what? Sorry.
I'm using the Jupyter notebooks within the data proc. So I think,
All set.
okay, so you are able to see my screen, right?
Yes. Yes.
Okay, great. So first of all, what we will do is we will try to create a Spark context. As I said, Spark context is a starting point. So the current version what we are using is 2.x, and prior to 2.0, which is the 1.x, we used to have the different context, like the Spark context or the SQL context to work with the Spark SQL, or the Hive context to work with the Hive. But what they did is they have unified all the different context into a Spark session. However, in this particular session, since we are using the RDDs, we will going to use the SC, which is the Spark context. So SC again is nothing but an object of a Spark context class. Now, first of all, before I discuss some of the operations what we can perform, I would like to demonstrate the lazy behavior. So here, what we are doing is we are trying to read a file, and this file is not present onto my GCS bucket or on this particular location. Let's see what will happen. So you could see some number here in the Jupyter notebook, which means that this particular statement has been executed. And although the file is not present, but we haven't received any error. Let's try to perform some operations. So this map is a kind of transformation. So we have performed a transformation on file RDD, and we have generated another RDD named as RDD1. Nothing happened. We haven't received any error. Let's perform another map operation, and we have created an RDD2, and we could see we haven't received any error. So far, what we did is we have read the file, performed a map operation, and we haven't received any error, given the fact that the file itself is not present. Let's try to perform an action. So count is a kind of an action. Now, as soon as I performed an action, what it will do is it will refer to the DAG it has created, and it will execute the statement in the sequence by referring to the DAG. So the first statement is read the file from a particular location. Now, since the file is not present, I believe this is why we are getting the error, and you could see the error input path does not exist. This is what I meant when we say Spark works in a lazy fashion.
So would that tell you then which RDD has got the error or where the error is?
So if you look here, it says the input path does not exist, which means that when you're trying to read the file, you got an error. However, if you have these many statements, it won't tell you that at what particular line it is breaking. That is something which we need to figure it out. But it will give you an error, something like this, which can help us to identify where it is failing.
Okay, so you'll have to go back manually and find where that is coming from.
Absolutely.
Okay. Cool.
There are some ways. For example, before writing a very big transformations, what we can do is we can perform certain actions as an interim check, and we can say that yes, this particular piece is working. And there are a few other ways we can try.
I see. Yeah. So you'd block it out into groups and then find out which has the error. Yeah.
Yeah. So what I could have done is after reading a file, I could have done a quick check here by doing, let's say, a count or any other simple action, just to make sure that the file is present and I'm able to read the file successfully before processing the file itself.
Yeah. Cool.
Okay. Great. So I just to be time conscious, I would just like to go with few more operations. So here, what we are doing is we are trying to create a simple RDD, the way what we discussed in the presentation. So let me create an RDD, and let me first show you. So you could see the type of num RDD is an RDD class, which defines that this num underscore RDD is an RDD, and these are the elements within the RDD. Okay. Transformations. So we have a lot of different transformations like map, filter, flat map. So I won't go into all of the transformation. However, you can go into the various transformations as per your own pace. I will share this notebook, and also I will share some of the blogs which I have written, which have a lot more examples around it. But I'll explain some of it. So let's discuss the map transformation. So what map will do is, map will map each element of your input to some sort of output. So here, what we are doing is we are performing a map operation on num RDD. So, and what operation we are performing is something we have specified inside the map as an anonymous function or as a lambda function. So what this say is, for each element of my RDD, just multiply this by 2 or double the element. A very simple map operation. So if I execute this, what will happen? It will return another RDD called as a double RDD. And when I display the content of this double RDD, it will display the content, which will basically be the values double the original values. So the original values was 1, 2, 3, 4, 5. Now we have doubled the values. A very simple map operation, but this is how you can map your input to some sort of output. Okay, filter, as its name suggests, it will be used to filter the elements from the RDD. So here what we are doing is, for the num RDD, we are filtering the data based on the condition where we say its modulo with 2 is equals to 0, which means it will give us only the even numbers. And here we could see we only get the even numbers out of it. Okay. Similarly, let me discuss just a couple of more transformation before we wrap up. So the one is the flat map. Flat map will work in a pretty similar manner the way map works. The difference is it will flatten the internal structure. What does that mean? So first of all, in order to understand, let's do a map operation. So for each element, what we are doing is we are returning a range object. So for 1, we are returning a range from 1, 1, which is basically an empty. For 2, it will return a value 1. For 3, it will return a range object from 1 to 2, and so on. Since we have used only the map operation, we could see we have got the list of list. However, what if we would like to have all the numbers, but we won't like to have it as a list of list, but we would like to have only a list. So we can perform a flat map operation. What it will do is it will flatten the structure to one level, and you could see we have the result is same. It's just that the structure is a little different. Okay. Similarly, we have a lot of different other transformations like reduce by key, group by key, sort by for the sorting, and lot more. And then at the end, we have some sort of actions, which is basically like which we need to perform on the top of RDDs. So let me just quickly show you a couple of actions. They are pretty simple, straightforward. So for example, here I have created an RDD, and the count action will give us the number of elements within the RDD. The first action will give us the first element from the RDD. The collect operation will give us all the elements from the RDD. However, as I mentioned, we should not use the collect operation in the production environment, because if your RDD is large, what it will do is it will collect all the partitions from the different workers to the driver. So it will overwhelm the network because all of your data has to travel across the network, and your driver will have all the RDDs, and it may go out of the memory error as well. So in order to avoid that, you can use the take function, which will basically give you the sample of your RDD. So you can control the number of elements out of it. Now with that, I would like to say thank you to everybody. And before going to a Q&A session, I would like to share a couple of links here with everybody. So here, this is the blog, which basically talks about what we discussed today about the RDDs, and also the different operations, the different transformations. So if you like, you can check that. And also I've included the link for the official documentation as well. And just to give you a bit of context regarding the next session, that if you are interested in attending the next session, what we will going to discuss in the next session. We're going to discuss the Spark SQL API or the data frames, which is basically the structured API. So this will help us to analyze the structured data. So we will discuss what are the data frames, the different operations which we can perform on the data frames, how we can read the data from the Hive table, how we can save the data to the Hive table, be it a managed Hive table, external Hive table, or the partition Hive table. We will also discuss how to work with the CSV file. So if you have the CSV file, how you can read the data into Spark, process it, and again back whatever you would like, or how to work with the Parquet data as well. So this will be the high-level agenda of the next session, if you're interested in this. And with that,
Yeah.
Yes, over to you, Joe.
Yeah, cool. Thanks for that, Neeraj. I thought that was really cool, actually, and especially the examples at the end that you showed us. So the blog post and the slides that Neeraj was just talking about and showed us briefly, we can make those all available to everyone, so we can send out links to Neeraj's socials, including his Medium blog post as well, which goes into a bit more detail than what we have today. So it's really cool. So I'd definitely recommend checking it out if you are getting into Apache Spark. So yeah, thanks again, Neeraj. We've got a few questions that have come in. If we'll go straight on to them. So we've got, I'm not too sure who this was from, but is Hadoop mandatory to run on Spark?
If you want, you can run the Spark standalone as well. For example, you can install Hadoop. You can install Spark on your local system, and you can still leverage that. However, like this is a part of the ecosystem because Spark only provides the processing component. So you need the other tools also to work with respect to along with the Spark. For example, you need storage, which you can use either HDFS or any other distributed storage like blob storage like S3 GCS. And you need some sort of, let's say, the resource management component, which is either Yarn or Mesos. So yeah, I mean, these are the components which works really well together. But to answer your question, if you want to execute it standalone, yes, you can install it on your local system and you can use only the Spark with your local file system as well.
Cool. I hope that answers the question. Like I said, I'm not too sure exactly who asked that, but what I've done, I'll just put a link to, oh, that was Jatin. Thank you very much, Jatin. I'll just put a link to Neeraj's Medium account on the chat bar as well, so everyone can access it now if they wish. Got another question from Hamad. I think we spoke about this briefly earlier. He's asked, is there a limit of data storage? We spoke on that briefly.
Yeah, so I mean, there is no limit on the data storage. For example, so you can create the cluster as big as you want. Like you can increase the number of nodes into your cluster. You can increase the memory within a particular node. So it's absolutely up to the hardware, like what you're trying to use. The bigger cluster you can create, the more data you can fit in. However, in terms of the optimization, as I said, Spark will also do quite a lot of different optimizations on its own. And also, like while building the ETL pipelines, we can also take care of certain things so that we won't overwhelm the cluster or memory.
So that's more of a hardware thing then, in terms of the actual storage itself.
So yeah, I mean, if I say the limitations, so there is no as such hard limitations, I would say, but there are different ways we can do the memory management at a different levels.
I see. Okay, cool. We've got another question here. Again, for some reason, I can't see who's asked this. Ejimofor. Apologies if I'm pronouncing that name completely wrong. But they've asked, is Hadoop's HDFS being depreciated, and why? What's its replacement? Does that make sense to you?
Yeah, not really, I would say, because internally, even if we are creating the clusters, it is using the HDFS. However, while storing the data, like we can use the other blob storage as well. So yeah, I mean, a simple answer is no, I don't think it is getting deprecating as per my understanding. But yeah, along with that, we can use the blob storage as well to store the data.
Okay, cool. So we've got another question here from Anchor. So new to Spark, this is the first learning session that they've attended for Spark. Hope you've enjoyed it. So they've asked, obviously, with the recent release in June, I think it was, of Spark 3.0, should they start with Spark 2 or should they go straight into 3? What's your thoughts there, Neeraj?
So, I mean, to be honest, I haven't got a chance much to explore the Spark 3.0 yet. However, like if you would like to get started with that, you can absolutely get started maybe with the 2.4, which is like before the 2.3, before the 3.0, like one of the stable version. Or you can also explore the 3.0 because they have made a lot of different, I would say, the performance enhancement in that, and they have also increased the capabilities of the SQL API and a few other APIs to give you a bit more tools to play around with the data.
Yeah, I think that was only released on like the 18th of June, I think, wasn't it? So
yeah, it's a fairly very new, absolutely.
Yeah, of course. Thank you, Anchor. They've just again commented saying that they've enjoyed the session. Glad that you've enjoyed it. Make sure you sign up for next week as well. It'll be good to see you there. A few more questions are rolling in. Let's see. We've probably got time for 2 or 3 more. We've got one here from Alex. Which cloud provider do you recommend to run Spark in? AWS, Google, Azure? Do you have a preference there, or?
I mean, to be honest, I mean, I don't have seen any sort of preferences because like all the cloud providers will provide the managed services, I believe. At least I know AWS and GCP because I have worked with that.
Yeah.
And also, if you want to install or the build the Spark clusters on your own, you can do that. And also, you can use the managed services. For example, if I talk about AWS, they have the managed service called as a EMR. And with the GCP, we have like the data prop, which I have used today. So, yeah.
So no, in particular, really, that
I don't
stand
think
out
there
in
should be
terms of
any
preference.
I mean, like I haven't experienced that. I would say.
Yeah.
So
Okay.
far.
Yeah, that's fair enough. Thanks for your question, Alex. Hope that answers it well. In the Spark API, sorry, who's this from? Let's have a look. So this is from Nick. In the Spark API, should you use experimental classes? Would there then be an issue for possible depreciated problems going forward?
I mean, that might be the case because that's why they say it as an experimental class because I mean that's the purpose of tagging them as an experimental class. So yeah, that could always be there. But if you like the functionality and if you like you would like to do that, I believe most of the code is open source and you can try to implement some of the code by yourself as well if you feel this could be an issue. But yeah. Oh, that is the reason like they put it as a experimental because they would like to keep it for some time until unless it will be more stable or they would like to make it more reliable in terms of the production usage.
Yeah, okay, cool. Right, I'll try and rattle through these last ones. Jatin has asked, are we going to discuss deployment architecture in the next session? So resiliency, failover, and availability. Is that something you're going to be covering, Neeraj, or something that we can cover?
So in the next session, we'll focus more on the data analysis. And so the resiliency, the failover is something which in some cases, Spark will take care of internally. However, if you're talking about the Spark administration point of view, so our focus is not on the Spark administration point of view. Rather, it's more of a data analysis, like how a data engineer or the data analyst can use Spark out of it. And
okay, cool.
what all things I'm going to discuss in the next session is something like I've already presented, and pretty much these were the things which we're going to discuss in the next session, which is pretty much around the data analysis and working with the different data sources.
Okay, cool. Thanks again for a couple of questions, Jatin. I think we've got time for maybe one more. We've got who we got here. It is Povilas. They've asked if collect actions collects all RDDs into one single entity. Is it rarely used in actual systems?
Yes, absolutely. And as I said, we should never use it if we can avoid it. But for example, there are certain operations which you need to perform, some statistical operations which you need to perform, where you need to gather all the data and you cannot perform that in a distributed manner. Probably you might have a need for that. But yes, if you perform the collect operation, the implications will be there. Why? We have already discussed that.
Yeah, cool. Thanks for your question, Povilas. Right, I've got one more then, Neeraj. We might as well get through it. So we've got here from Gennady. They've put, as you mentioned, we should not collect in production, but is there any case when we can use it?
Yeah, as I said, like for example, for some sort of, let's say you would like to perform a statistical operation which you can't avoid. You need all the data in order to perform the statistical operation, and you can't perform that operation in a distributed manner. That could be one way I can think of. However, the RDD API which we have discussed today, is not being used pretty much, and something we use like the data frame API, which we are going to discuss in the next session. Why
Yeah.
we discuss the RDD API? Because the Spark SQL is built on the top of the RDD APIs, so it's important to understand how the RDD APIs works under the hood, because the same behavior will be replicated to the Spark SQL as well. For
Yeah.
example, I would like to quote an instance, the question which I got quite often, which is like, let's say I have read the data either from, let's say, the CSV or Hive table, performed all the data analysis, and when we try to display the data or when we try to save the data, or the idea is when we try to perform some sort of action on top of it, that's where things have started slowing down or failing. It's because like that's where the things have started getting executed. And in order to demonstrate that behavior, we discuss the RDDs, because under the hood, even if your structured data, they will be converted into the RDDs.
Cool. All right. Well, we'll have to wrap it up there, Neeraj. Thanks again for joining us. Looking forward to next week. Thanks everyone for joining us and getting involved with the questions. Hopefully, we've got a lot more for next week as well. So we're looking forward to that. So sign up. It's going to be the same time next Wednesday, 1 p.m. UK time. And yeah, Neeraj will be back with a bit more of a sort of technical insight into the sort of data analysis of Apache Spark, and hopefully you can all join us. And yeah, looking forward to next week. Thanks again, Neeraj.
Yep, thanks, Joy. Thanks everyone for listening me, and I hope you have enjoyed the session. Looking forward for the next session.
Yes, stay safe, everyone. See you soon.